Okay, in this video we're going to talk about how to simplify imaginary numbers. And I'm going to put kind of two examples side by side. So the examples on the left side are just positive square roots, and then we'll do the same on the right side, but we'll just make those negative, because remember that we said before that I is equivalent to this. It's equal to the square root of -1. That's the definition of what the imaginary number is. Okay, so it's nice, it's easy when we can have what's called a perfect square underneath the square root. The perfect squares are these numbers right here. They're numbers that you get when you take a number and you multiply it by itself. So, for example, 9 is the same as 3 squared, 16 is the same as 4 squared, and so on down the list. Okay, the square root of 9 is equal to 3. How would we say, or how would we simplify the square root of -9? Well, think of it this way. We could write, and hopefully you agree with this, we could write the square root of -9 as the square root of 9 times the square root of -1, because that's what -9 equals. 9 times -1 equals -9. Okay, now what can we do? Well, the square root of 9, we already said that that's equal to 3. And this, what's another name for the square root of -1? That's another name for I. So the square root of regular 9 equals 3. The square root of -9 equals 3i, or 3 times I. Okay, let's apply that same type of reasoning to what's called a non-perfect square. So like 8, for example. 8 is not a perfect square because it's not in this list right here. But we could use the following strategy. We could find a perfect square that's in 8 and factor it out. And what I mean by that is 8 is the same thing. If we look at this list right here, notice that 4 goes into 8. Okay, 8 happens to be equal to 4 times 2. The square root of 4 is equal to 2, and then I can't simplify the square root of 2 any more than it's already simplified. So another way of saying 8 is 2 times the square root of 2. How would you do that with -8? You would do pretty much the exact same thing, except as our first step we would pull out a -1 from 8, because 8 is the same as -1 times +8. Okay, then we could keep going. So -1 times, we know again that 8 is 4 times 2, root 4 times root 2. Okay, this equals I, that equals 2, and then we're multiplying those together. So the the square root of 2 stays underneath the root. And our final our final answer for this would be, normally we put the number in front and then the I comes after it, and then the radical comes at the end. So a final answer here there would be 2i root 2, almost the same as this. This is just regular 2 radical 2, or 2 times square root 2. This one is 2i root 2 because there's a negative. So kind of simple way to think of it, whenever you see a negative in front, simplify it like the regular square root, and then just stick an I next to it like you saw me do right there. Alright, let's do a couple more of these, and I encourage you to try to pause the video and see if you can do these yourself. Before we do that, I'm just going to add negatives in front of all of these so that we can do it with imaginary numbers. So those all have negatives in front. Let's start with number 2. We'll come back to number 1. Number 2 is the easiest. The square root of regular 16 is 4. So the square root of -16 would be 4i. And that's all you need to do. Okay, this one right here, number 1, we can pull out the -1. And then in our list of perfect squares, I'll rewrite it right here. What's a perfect square that goes into 18? Turns out to be +9. 18 is the same as 9 times 2. So this again equals I. This is equal to 3. And that we can't simplify any further. So our final answer, we normally put the 3 or the number in front, the I comes after it, and then the radical 2 goes right there. So 3i root 2. -48, same thing, -1 times, and then what's a perfect square that goes into 48? Now you might say, well, 4 goes into 48, and that's true, but it's always a good idea to look for the largest perfect square that goes into 48, because that will enable you to cut down on the number of steps. If we pick 4, we would use 4 times 12, but then we're going to have to do the same thing with 12. We have to break 12 into 4 times 3. So it's better to use the largest perfect square. And in this case, the largest perfect square is 16. 48 is equal to 16 times 3. So if we simplify this, this is again I. That's equal to 4. That's equal to square root of 3. So we can simplify that as 4i times the square root of 3. And that's all we can do with that. That's as simple as it gets. Okay, -24 is the same as -1 times 24. And what perfect square is into 24? Well, let's start at the highest number. 25 is obviously too big. 16 doesn't work. 9 doesn't work. 4 goes into it though. 24 is 4 times 6. So that equals I. Square root of 4 equals 2. Square root of 6 stays the same, so our final answer is 2I times square root 6. So what we just did is we basically took radicals or square roots and we simplified them by first of all pulling out the I, and secondly finding perfect squares, meaning numbers that are multiplied by itself. So hopefully that made sense, and we'll see you in the next video.